This is Sai Samantha from Civil Department, Dreams Polytechnic. Today in this lecture, we are going to establish the relation C. This is our RCC block having dimension B and effective depth D, and from the stress strain diagram of the mild steel we are getting this strain diagram. At this top value is 0.0035 and the bottom FY ratio 1.15 ES plus 0.002, and this is our neutral axis. Okay, this is stress diagram of concrete, and here rectangular section and here parabolic section. See, the upper part is rectangular and the lower part is parabolic in nature, this one. And here is the tensile force, okay, T. Here is C. Now we are going to find out the relation XU ratio D is equal to 700 ratio 1100 plus 0.87 Fy. For this, see, this is our first C1 here, C1 here, C2, and this is combinedly C. So at the junction of rectangle and parabola, the value of strain is 0.002. So I will name like this: OAB, CD, EF. OAB and OEF triangle. If I will assume these two triangles, then OA ratio OF is equal to AB ratio EF, implying OA value is 0.0035 ratio OF value is, see, this is neutral axis, means from the top the value is XU, depth of the neutral axis. XU means total is D up to neutral axis. XU means this value will be D subtract XU. So here we will put OA value is C XU subtract ratio. OA value is D subtract XU. AB value is 0.0035, which I have written here. Ratio EF value is FY ratio 1.15 ES plus 0.002. If I will add XU in the numerator and denominator, it will convert into 2xu, and in the denominator only d, and in the right hand side of the equation I will add 0.0035 in the numerator and denominator. So I will get 2 into 0.0035 ratio Fy ratio 1.15 ES plus 0.0055. Okay, and we know the value of ES is Young's modulus of elasticity for steel, which is equal to 2 into 10 to the power 5 Newton per meter square. So 2 cancelled here, both sides. We are getting XU ratio D is equal to, see, ES, if we will take LCM, it means here ES will be multiplied, and at the bottom means at the top it will be coming. Okay, so simply 0.0035 ES ratio Fy ratio 1.15 means 0.87 Fy plus 0.0055 ES. Putting the value of ES 2 into 10 to the power 5, we are getting XU ratio D is equal to this one 700 in the denominator 0.87 Fy plus 1100. First equation. Then from the triangles OAB and OCD we are getting, see, OAB and OCD, what we will get? OA OC ratio OA is equal to CD ratio AB, implying OA value, OC value is OA into CD ratio AB. So OA value is XU into CD ratio AB, means CD value is 0.002 ratio AB 0.0035. From this we will get 4/7 of XU is the value of OC, which implies AC value is equal to OA subtract OC, which is equal to 3/7 of XU. Now we will find what is the value of C. C is nothing but the compressive force, equal to C1 plus C2. C1 for the rectangle section, see this one, rectangle section, and C2 is for parabola. So this one is C1, this one is C2, combining it will be C. Clear? So from the stress strain diagram of concrete, we know that 0.45 FCK is the stress at the outermost fiber, concrete fiber. Okay, outermost layer of the concrete. The value of stress is 0.45 FCK, and C1 will be, see, stress 0.45 FCK is the stress into area is B into this value is, see, 3/7 of XU, this value is 4/7 of XU, though we are finding out for the rectangle part. So B into 3/7 of XU. Okay, this one C1, and for C2 same 0.45 FCK, B into 4/7 of XU is for rectangle, but this is not rectangle. See, this is 1/3 of the rectangle. lower part is 1/3, upper part the parabola is 2/3 of the rectangle, so it will be 2/3. This one is C2. So if we will add these two, we will get C value is 0.36 FCKBXU, and here we are going to find out the lever arm. How we will find out this one? See, D subtract 0.42 XU is nothing but the lever arm, because see, Y value will be C1 Y1 plus C2 Y2 ratio C1 plus C2, and here Y1 will be for rectangle D ratio 2. Here D is 3/7 of XU into half value will be Y1, and for Y2 4/7 of XU (3/8 of 4/7 of XU) plus the upper part 3/7 of XU. This is nothing but 9/14 of XU. This is 3/14 of XU. If I will put all these values Y1, Y2, C1, C2 here, I will get 0.42 XU. Okay, which is the point at which C is acting. C is acting at this depth 0.42 XU. This is C. C is acting at 0.42 XU, means total depth is D. See here, total depth is D and C is somewhere acting. This is C. This is C. C is acting at 0.42 XU. This height 42 XU. So between C and T we are going to find out the lever arm. Lever arm is nothing but the perpendicular lever arm. This one is lever arm equal to D subtract 0.42 XU. See, total depth is D and 0.42 XU is the Y. We are subtracting. See, this one is total depth D and 0.42 XU is this. From where C is acting, C and T, this distance is called lever arm. Clear? So this will be D, total depth is D from this point to this point, and from this point to this point is 0.42 XU. So this will be D subtract 0.42 XU.